So I went over the whole thing with intermolecular forces a little bit so far, but I'm going to go a little deeper into it now. Remember, water has very strong intermolecular forces because it has hydrogen bonding. And something like acetone or rubbing alcohol will have weaker, like alcohol, acetone, those will have weaker intermolecular forces. So weaker intermolecular forces, they're not held together so tightly, so it's pretty easy for them to leave the liquid and become a gas. So let's say we have like some molecules here, right? And they're all kind of like meh, right? They're not held together very tightly. They don't care much about being together. Whatever. Like, if I want to go, I'll go. I'm not really tied down here. If I have a strong intermolecular force present, it would be more like this. They'd be all together, and they'd be like, no, I love you, I don't want to leave, I can't leave, I'm staying here. We're held too closely together, right? So if they feel like leaving, they'll leave. These ones, they leave, but it's not as likely to happen. It's not going to happen as frequently because they're being held really close together. Okay, so what does that have to do with the vapor pressure? These are not held tightly together, so they're ready to go from being a liquid, which is kind of close together, to a gas, which is not close together at all, right? So that's going to have a high vapor pressure. You're going to have a lot of vapor coming off of it because it's ready to turn into the gas state. What does vapor pressure have to do with the boiling point? Vapor pressure is the point at which, boiling point is the point at which the vapor pressure, right? So boiling point is vapor pressure is equal to the atmospheric pressure. So if you have very high vapor pressure, you're very willing to turn into a gas. You're going to turn into a gas right away, right? You're not going to have to add too much heat in order to boil. On the other hand, if you have strong intermolecular forces, you're not going to be turning into a gas anytime soon because you want to stay together. You want to be a liquid. And if they really want to be together, right, you're going to have to put in a lot more energy to pull them apart and make them into a gas. And I'm just going to skip over colligative properties for now because we're focusing more on reading table H right now, which is, if you go to your reference table, you scroll down, 4, page 4. So I'm going to skip over the colligative properties stuff, and we're going to talk about more of the table H things, so reading table H. So now go to page 3 of those notes from February 27th, and we will get more into table H. Okay, so table H shows the vapor pressure in kPa of 4 liquids as a function of, and so we have vapor pressure, right? And when it's asking you something as a function of, right, so we have vapor pressure is a function of temperature. When it says function of, it's talking about what the other axis is. Okay, so temperature. All right, so now let's take a look at reading it. When the vapor pressure of water is 30 kPa, what is the temperature? Okay, so now, right, we're looking at kPa here, 30. It looks like these are going in tens, right? 1, 2, 3, 4, 5. Good. Okay, so 10, 20, 30. 30 kPa. And I'm just going to draw a big fat line here. Now I'm going to find water. And I'm going to trace that whole line to make it easy for us. All right. So it's asking me what the temperature is at 30 kPa, and that will be this point right here, where the temperature and the vapor pressure line meet. So my temperature, this looks like it's going in fives, right? 50, 55, 60, 65, 70, 75. Okay, so my temperature there will be 70 degrees Celsius. Okay. And which graph best represents the variation in vapor pressure of water as temperature changes? So let's look at these, right? These four. Which of them looks most like this? It's going to be this one, right? That's the one that looks most like those. And we also said that as temperature increases, vapor pressure also increases. So that would be choice C. Okay. So the vapor pressure does not depend on the amount of the liquid.